How does convection create a thermal boundary layer? Imagine you're holding a hot cup of coffee. As the heat rises from the liquid to the air, something interesting happens right at the surface. That's where the thermal boundary layer begins to form. When fluid flows over a surface that's hotter or cooler than itself, a thin region develops where heat transfer is different from the rest of the fluid. This is called the thermal boundary layer. It's like a small zone where the temperature changes rapidly from the surface temperature to the temperature of the bulk fluid farther away. Convection is the main process here. It's how heat moves through fluids like liquids and gases by their movement. When fluid flows over a heated or cooled surface, the molecules in direct contact take on the surface's temperature. But because fluids resist flow due to viscosity, the fluid right at the surface can't move freely. This is called the no-slip condition, meaning the fluid velocity at the surface is zero. As you move away from the surface, the fluid speeds up gradually. This change in speed creates layers of fluid sliding past each other, which causes friction. This friction isn't just about movement, it also influences heat transfer. The layers of fluid near the surface get heated or cooled, creating a temperature difference. Because of this difference, heat is transferred mainly by conduction within this thin layer. Conduction is the process where heat moves through molecular collisions. Outside this layer, convection takes over, mixing the fluid and spreading heat more efficiently. The thickness of this boundary layer depends on how well the fluid conducts heat and how fast it flows. If the fluid has high thermal conductivity, heat can diffuse more easily, making the boundary layer thicker. Faster flow speeds tend to make the boundary layer thinner because turbulence and mixing increase, helping heat transfer happen more quickly. This is why in some systems, increasing the flow speed can improve heat transfer efficiency. Understanding this boundary layer is important because it controls how quickly heat moves between a surface and the fluid. In practical applications like cooling electronic devices or designing heat exchangers, managing the thermal boundary layer can make systems more effective. If the layer is too thick, heat transfer slows down. If it's thin and turbulent, heat moves more rapidly. So, convection creates a thermal boundary layer by generating a temperature difference near the surface. The flow causes a gradient in temperature and velocity, leading to a region where heat transfer is dominated by conduction close to the surface and by convection farther away. The properties of the fluid and the flow conditions shape how thick this layer becomes and how well heat can transfer through it.